this session. Before I hand over to our important and prominent guest, I'd just like to make two quick announcements. So one is I will try to wrap this up in 90 minutes. Okay. And if you manage that, we'll all go to the Politerrasse, to the student bar. And we can just have drinks and have chats if you need one more question. The second announcement is that, and I was instructed to do this by my manager. So the team, my team, which is located here at the ETH University, is hiring. So we have an open Python position. So if you're interested in doing interesting open source work with Python, okay, come and see me afterwards, or email me, or write to me. Okay. That's all. Okay. Guido van Rossum is a very well-known and very highly regarded persona in the computer science field, so there's no need to announce him greatly. I'll just hand over to him, and maybe we should greet him with our first round of applause.
Well, thank you. Let's see, I have a small collection of slides, and I think if you were here a few minutes ago, you already saw most of them. But I have something to say for each slide. This is actually, I hope this is going to be the last time that you do a particular talk. I did this for the first time 4 months ago at PyCon in Santa Clara. I did it again last week in Europe PyCon. Yeah, I can call it not the state of the Python Union. It's really sort of my current high-level ideas about where Python is, where we go, and how you should think about it. And sort of so maybe it is the state of the Python Union, except I have nothing about very specific features of the language, more about people and process. So first, I'd like to thank the Python Software Foundation. That's a non-profit that started in 2001. It was created with the specific purpose of owning the copyright to the Python code, source code, so that from then on, nobody else could claim that they owned Python and could thereby try to limit the use that people could make out of it. That's always a smart thing to do as a sort of an important open source project. The BSF sort of had a slightly rocky start, but eventually became very successful, organizing PyCon conferences in the United States. And those conferences usually sort of accidentally, happily bring in a small profit, and that profit is then part of the sort of the start capital of next year's conference. But it also is given back to the community in other countries, other sort of local places. If people want to organize a smaller Python conference that is accessible for people locally, whether PyCon UK or PyCon Germany, or if someone feels like setting up a PyCon Switzerland or even a PyCon Zurich event, the BSF doesn't just sort of tell you that's a great idea, yes, go do it, but they'll also give you some money for, I don't know, pizza or travel costs to invite an important speaker or some sort of sponsorship, just to support Python communities, support people spreading the word. So BSF is a very useful organization, and they don't just own the open source copyright anymore, although they still are very busy with that part too. So finally about this photo, this is actually a woman in Japan named Yuko Honda, she's sort of a geek fan. She likes open source, she likes to use open source, and to give back to open source in general. She draws logos of various open source programs. She has a Flickr website with, I think, several hundred of these. And she draws them very carefully in a latte. Just sort of, I think she has some wooden sticks that she uses to shape it just right. And she pours a little extra milk on it, and then sort of, she's really creative, a very creative person in sort of making sure that these things look the way they should look. So I thought to honor her by showing her art. Okay, so the subtext of the talk is how to deal with trolls. Because if you're a Python fan, you every once in a while you get to deal with trolling questions. So what exactly is a troll? It's either leading question whose point is not to actually get an answer, but just to provoke an argument that will drag on and on and on, whereas supposedly the person asking the question somehow wins the argument, but usually what happens is that there's just a shouting match and no information is being exchanged. Sometimes the person asking the question is also considered a troll. Trolls happen very often in all kinds of online media, and my general response is, as soon as I detect that something is a troll, I stop responding. Don't feed the troll. However, there are lots of situations where you can't really do that. If someone meets you at a party or some other event, and they say, hey, I see that you use Python. Well, I happen to think that Python is a really lame language, and this is why. There are a couple of different ways that they can present that, and I have answers for all of those. So it used to be that long ago, like 15 years ago or so, when most people hadn't, of course, heard of Python, not even most programmers. But when people did hear about Python, they heard there was this crazy language that used white space instead of curly braces. If you haven't tried that, for most people, it seems a very strange idea. To me, personally, it always felt completely natural, because when I was reading source code, I was using the white space as my primary clue about the structure of the code anyway. The curly braces were just there for the compiler, because the compiler was too stupid to see the structure otherwise. So I was very happy when I discovered some other languages that use white space. But somehow that idea that the white space was actually important for humans to understand code didn't catch on immediately. So a lot of people immediately rejected Python based on the white space. Eventually we discovered a very effective answer to that, which is you must not have tried it yet. Because every person who tries it very quickly discovers, oh, actually, that white space stuff is what I've always wanted to use when coding. So these days the trolls are, well, more sophisticated. They've heard other things about Python that are not completely wrong, probably not completely true. So one thing that you often get is, oh, my language is so much better, my favorite language is so much better. And I'm sure as a Python fan, you may have done that to someone who was all excited about Java or Lisp or Ruby. Actually, my idea is that Python and Ruby, for example, and a whole bunch of other languages that are considered dynamically typed languages are actually very close. Python and Ruby are much closer to each other than either of them is to C++ or Java. And actually, you can extend the group if you add Perl, Tcl, even JavaScript. Those are all dynamically typed languages, and they all actually have more in common than they differ. So they're especially when someone says one of their favorite language is some other dynamic language, you should congratulate them, say good for you. Python and Ruby actually share a lot. I've met Mats, the Ruby guy, a couple of times. He's actually a really neat guy. He freely admits that his hero is Larry Wall, the author of Perl, and Mats' idea is to create better Perl. But he actually also stole a lot of ideas, and I mean that in the best possible sense, from Python. Because all these languages actually borrow from each other and play off each other. So I think this language comparison game is kind of silly, and especially when we're all open source languages, it makes much more sense to support each other. Every once in a while I get invitations actually from language conferences that focus on other languages. The most recent one I got, unfortunately, was not in a location or time that I could make it, but there's a conference, I think it's called PyRu, and it's actually about both Python and Ruby. So those are people who totally get the idea that Python and Ruby are much closer than they're different. So there are much better ways to spend your time than actually arguing, oh, Python's if statement is better than Ruby's whatever. Python's for loop is easier to understand. Just share and enjoy. So another topic that probably for the last 5 years or so has brought up a lot of commotion is Python 3. People have actually compared it to Perl 6, which I don't think is quite fair. Perl 6 is a completely different language that maybe was inspired by Perl 5, just like Perl 5 was inspired by Perl 4, but Perl 6 is sort of, it doesn't feel constrained by anything in Perl 5. It's a different implementation, different sort of philosophy about designing the language, and sort of, as a result, it's also a different community. The Perl 5 people are just happily improving Perl 5 and sort of maintaining it and adding new features to it and bringing out new releases regularly. And the Perl 6 community is frankly much smaller and sort of doing their own experimental thing and sort of trying to figure out if it all makes sense. The Python 3 story is completely different. We had the advantage of starting by the time I could sort of see where the Perl 6 story was going to end up. Python 3 is an attempt to, with moderation, which is something I like to do a lot of, well, still in moderation, but I often find it easy to argue both sides of a coin, so I often end up somewhere in the middle. So Python 3 sort of says, well, Python 2 was a pretty good language, and there were some issues. Let's see what we can do to address those issues that look like they're really important to address, and that we may not be able to sort of evolve the language in place. Because of course, it's much easier to not start a new version of a language, but just sort of gradually change the language and say, well, we're still backwards compatible, but we also have this tiny new feature that sort of eventually blooms into a big new feature. And then you can start deprecating old stuff. But that takes a long time, and not every sort of change you want to make to a language actually can be done in a backwards incompatible way. In a backwards compatible way. I'm sure you can do everything in a backwards incompatible way. That's a good way to chase your users away. So, for Python 3, as a language community and a core language developers community, we started with lots of discussions, sort of, what are the things that are most in need of fixing in Python? Well, Unicode was one of the things that was high on everybody's list. And so Unicode was one of those things where we had sort of essentially designed ourselves into a corner with sort of compatibility between 8-bit strings and Unicode strings in certain conditions, but no compatibility in other conditions. So that sort of the type of two strings is not enough to determine whether you can actually combine those two strings in, say, a concatenation operation. Because an 8-bit string, if it actually internally is a 7-bit string, it's pure ASCII, classic ASCII, then you can combine it with the Unicode string. You can concatenate the two. On the other hand, if another 8-bit string, which has exactly the same type as the first one, but it happens to contain even a single character that has the high bit set, then you cannot combine it with the Unicode string. We thought we did that with a very specific purpose about sort of gradually introducing Unicode in the hope that people could sort of start using it where they needed it without being distracted when they didn't need it. And it took a long time before we realized that there was a certain type of mistake that was very common in programs, where people basically lost track of what is an encoded string and what is a decoded string. And so you end up with sort of trying to encode a string twice or trying to decode it twice. And the annoying thing was, again, that if something is a 7-bit ASCII string, you can encode it and encode it and encode it, and it remains the same string, and same with decoding. So you can have all sorts of hidden bug in your code that would only happen to trigger an error when, let's say, the first time you launch your website and one of your users is from Germany and they have an umlaut in their name. And you might not have sort of typical parochial Americans don't type these characters. So in America, every name is ASCII, almost every name. And so you sort of, you think you've tested all your code, and then you make it live, and then suddenly you have all these unexplainable errors. So that was the problem we had with Unicode. And we thought about it a lot, what is the cause of the problem, and we ended up deciding that there was no way we could fix that without having some kind of incompatibility in the language. We had to force programmers to sort of actually know where in their code they were using Unicode and where in their code they were using bytes that were still encoded. So that was an example, just a very elaborate example of something that we figured we couldn't fix in a backwards compatible way. And sort of we went on and we looked at all kinds of annoyances. And like the Python 2 has two kinds of integers. It has so-called short integers, which are 32 or 64 bits, depending on the platform. And long integers, which are actually arbitrary precision. And so for many reasons, for many situations, you can pretend that the long integers don't exist, or you can also, if you want to, pretend that all integers are long integers, and mostly that sort of works. But every once in a while, you sort of enter a situation where somebody says, this argument must be an integer, and then when you pass it in a long, even if it has exactly the same value, you can sort of, the number 4 can be represented both as a short integer or as a long integer. They compare equal, it's the same value, but they're different types. And so if someone somehow decided to check for the type of an argument because they said this can absolutely not be a string or something else, they happen to write that as assert is instance x of int, then if you sort of pass in a long as the right value, it still has the wrong type, and their code bonds. So again, we decided to just get rid of the long type completely. We had a bunch of other things. I don't want to sort of go into a list of features of Python 3, but in the end, we had a whole bunch of things that we figured we really wanted to fix, and we couldn't think of a way of fixing these things without introducing a fairly significant amount of backward incompatibility. So we ended up saying, okay, that's what we're going to do. We're going to help everybody, we're not just one day going to announce that Python 2 is no longer supported and everybody has to switch to Python 3. We're going to sort of develop Python 3 and then gradually push people sort of over and give people a long time to sort of get used to the idea that Python 3 is the new version and Python 2 is no longer all that modern and fashionable. And so that's what we've done. When we started the Python 3 project, we knew we were in it for the long haul. We knew we had to sort of spend a lot of time supporting both versions of the language in parallel. And we worked on a number of tricks to sort of make that possible. And we're still working with the community actually to get more people to start using Python 3. Every year, I see more sort of hopeful signs of Python 3 gaining more critical mass, gaining more momentum. For example, Django, Python's biggest, maybe most well-known, I don't know, most used web framework. Django announced a couple months ago, I think just before PyCon actually, that Django 1.5, which is coming out this fall, will actually support both Python 3 and Python 2. That's huge news because it means that people who want to start developing new Django applications and who want to start using Python 3 can now start using it. Many other projects have done similar things. Numeric Python, NumPy, has also done a similar thing. I'm not quite sure of the status. I believe they actually have had a couple of releases that support Python 3 completely, while they're also still supporting Python 2. So I think that sort of seeing major open source projects that are important for the Python community migrate, or at least start migrating to Python 3 is going to send a very positive signal to other people. Whereas the first people who switched were sort of people who were teaching Python in a classroom where the students were sort of just learning to program. Because Python 3 really is a better language to start learning to program. There's lots of little details that are improved. And when you're sort of just learning to program, compatibility with the previous version of the language is not even a concept you sort of care about. So those people were the first. The last people to switch to Python 3 are probably very large organizations that have internally developed code bases with millions of lines of Python code. And even though I'm not here as a Googler, I can say that Google internally has a lot of Python code, and that Google will probably be one of the last organizations to switch to Python 3. At the same time, we are working on it. We have people looking into this transition already. It's just sort of a plan that will take multiple years. So I don't think Python 3 was a mistake. That's why I put Python K on my license plate. And then my commute changed and my wife drives it, which is always fun. Okay, so completely different direction. This snake, the Ouroboros, is the logo, official logo of PyPy, which started out as Python implemented in Python. That really is not the sort of the current focus of the program, although they still use an internal sort of subset of Python called RPython, which they can translate to C. And sort of they bootstrap their system. But really what PyPy is about at the moment is a just-in-time compiler that can execute Python code much faster in practice than the sort of traditional Python implementation that we call CPython runs. PyPy has, they started out less than 10 years ago, but certainly more than 5 years ago, with sort of very lofty goals and some very smart people on the project and sort of no immediate results, but they knew they were onto something. They managed to rally up some European community support. They worked on it really hard, and after a number of years they started reporting that they actually, first of all, they implemented the entire language. Second of all, they ran the entire language as fast as CPython. And third of all, they had not yet run out of ideas of making it faster. So that was when it sort of started looking interesting. Maybe they'll end up 10 times faster than CPython, and then that would be a very interesting proposition. So where they are nowadays is that actually for most benchmarks, and they've actually done a good job of using sort of diverse benchmarks. The benchmarks are not sort of these things where you say add one to a variable in a loop and see how fast it goes, because of course a JIT can optimize that very efficiently, but can a JIT actually optimize an incredibly large program that imports hundreds or thousands of modules and executes a lot of code, not very often, but sort of like a typical web application using a web framework. There's a lot of code that gets loaded and executed there. But there are only sort of some places that are performance critical. So they actually worked very hard on supporting real-life, real-world Python applications, and they are now to the point where on most benchmarks, I think there is one exception which actually has to do with exception handling, which seems to be difficult for everybody who is implementing Python differently than CPython does. But the PyPy project is apart from that one thing, they're almost uniformly faster than CPython. So now the question is, why not just give up? Why not just adopt PyPy as the default standard Python implementation? And well, if that were possible, I would be the first to say, okay, throw away the CPython code, or at least sort of park it in a safe spot and don't develop it anymore. But it's not actually that simple. Most people who use Python don't actually seem to care all that much about performance. They care about other things, like being able to link to a lot of third-party modules, being able to load lots of different extensions that they wrote themselves or that were written by other people, sometimes dead people, or at least people who have stopped maintaining their code. So PyPy actually still has a long way to go being compatible, especially with C extensions. They have a number of very bright ideas about how to do that, and I'm sure that if we just collectively keep telling them, once you can run my favorite extension module, I will switch to PyPy. They'll get there. In the meantime, they haven't ported PyPy to Python 3 yet either. They currently, I believe, are completely compatible with Python 2.7. So that's another reason why CPython is still ahead of them, if you believe the previous slide. So anyway, PyPy is a great project. I still believe it has a lot of potential. I'm really hoping that they sort of make CPython irrelevant, but it hasn't happened yet. So in general, I like that there are other Python implementations. I don't feel sort of threatened at all by the existence of other Python implementations. For me, it's like it feels more like validation if someone else decides that they like your language so much that they're going to create their own implementation and maybe beat you at the game of writing a language implementation. I feel, okay, well, I guess my language design skills are okay if people do that. So what else? Well, here we get to sort of one of these issues of language design. Dynamic typing has been quite a topic for people who wanted an argument, so to speak. Some people have sort of fundamentally the belief that a compiler finds all their bugs, and the fact that that a language like Python, or Perl for that matter, or JavaScript, which they probably also don't like, the dynamically typed languages, the compiler doesn't find the bugs, really bothers them. Now, of course, yeah, I saw a bunch of people, I heard a bunch of people here smirking. There are, of course, lots of situations where static type checking doesn't find you bugs either. If you work with Java, I'm sure you know what a null pointer exception means. It means a program that passed the type system, but wasn't all that happy at runtime. There are many scenarios you can imagine where counting zero-based or one-based, counting meters versus feet, any number of misunderstandings between authors of two different components that somehow have to cooperate. So in practice, whether you are using a dynamic or a statically typed language doesn't matter so much. You're still going to have to write a lot of unit tests, do a lot of integration tests, and you're also going to have to use your brain. Programming is an activity where as soon as you stop thinking, you will start making mistakes. And that is completely independent from whether you have a statically or dynamically typed language. Now, I don't have any academic papers to back me up, but I have a feeling that the number of bugs in a piece of code that has been sort of written carefully and been tested and debugged some after a while, the number of bugs that remains is more or less constant per number of lines. I don't know if it's like 1 bug per 20 lines or 1 bug per 1,000 lines. But the sort of which language you're programming in doesn't actually matter so much for the that chance. Yes?
There's nothing on the internet which is called write the right stuff. And there is the numbers that you're seeing. It basically explains how the operating system for the space shuttle launches the shuttle into orbit. It was written. It has about 40,000 lines code and 13 words.
That's very well developed code.
The interesting thing is that since the project went so long, they had a simulation for every developer. So when the feature came in, they would assess the feature, and then they would say, this developer will do that feature, and then yes, only one code that will take, and then the simulation would say there are 3 bugs in there of this type and 2 bugs of that type. And the simulation usually is right. That's because we all make the same mistakes, personally.
Yeah.
That's every one of us makes the same mistakes over and over again. Different people make different mistakes, but the number of mistakes per line of code is basically constant per person.
Awesome. That sounds like really nice research. So yeah, of course, you might notice that when you write your code in Python, that there are just fewer lines of code, period, if you compare it to, say, a similar thing in Java or C++. So that might actually be an advantage if you sort of care about how many bugs there are left in your code. And yes, I've also been frustrated by poorly tested code that had a difficult bug that sort of looked like a typical dynamic language bug, like attribute error or type error. But believe me, I've debugged plenty of C++ and Java code and C code. And you have categories of bugs there that are just as nasty. So basically, to me, the static versus dynamic typing is a fairly uninteresting discussion. Different application areas can probably use different styles of languages. Different programmers have different needs. I think there's room enough in the world for both lots of statically typed languages and lots of dynamically typed languages. One interesting development I've sort of seen in the last 5 years or so is that language designers from the statically typed camp are actually coming up with hybrid language designs where they add certain dynamic features to a static language, where they try to come up with a language that, whole new language that has some static and some dynamic properties. So I think that if you look back 15 years ago, sort of mainstream, everybody believed that statically typed languages were better. And then maybe the web happened and dynamic languages sort of came out of nowhere to a very prominent place in web development and a few other areas. And so language designers have actually started taking notice and realized that, well, there's got to be something interesting in those dynamically typed languages, otherwise people wouldn't keep using them and be successful with them, frankly. Okay, one more thing about this, and then I'll hit next. Every large enough program, well, there's this old joke that says sort of every system eventually grows until it can send and receive email. Sort of a similar thing that I've noticed is that every large system eventually grows some kind of interpreter for a dynamically typed sublanguage somewhere inside it. It's amazing how often you'll find that you have completely statically typed code that is essentially just passing strings around or other sort of objects that are completely dynamic and where the static typing is of very little help except to sort of remind you that you're still passing an object of a certain type, so you're passing strings around, but what's in those strings is being parsed or otherwise interpreted or sort of has meaning, and effectively you're totally you're building a dynamic system. in a statically typed language. And so you have to still deal with everything that comes with that, like testing. So what else? Speed. So when people think their program is too slow, they think, well, there should be a compiler, and a compiler magically makes all my code faster. Unfortunately, that's not actually how it works. You can mechanically translate Python into C++. There was actually a talk at EuroPython of someone who was doing that. And you can find that it actually, first of all, is an enormous amount of work. Second of all, doesn't really run any faster than interpreted Python. The language has a lot of dynamic features that make it difficult to sort of compile it to machine code the way a statically typed language gets compiled. So dynamic languages work very differently. At the same time, it's not at all a done deal that every Python program has to be slower than a similar Java or C++ program that sort of does the same thing. I've seen examples actually in both directions. Of course, when you see a Java program doing something a lot slower than a similar Python program does it, the question is, how is that possible? Because for bytecode, Java is definitely faster. Well, one thing could be that what's happening in Python is actually often Python is just glue around very efficient C code or C++ code, and mostly C code. Core Python is all written in C. And all the hard work is actually C code, and all that the Python program does is just sort of tell the C code where the inputs and outputs are. Of course, if you're using a library like NumPy, that's how things work. But often when you're doing lots of string manipulation, actually the same thing or a similar thing is happening. Python's string operations are all implemented in C. Python's dictionaries are an incredibly optimized hash table implementation. Python's lists are super optimized variable length arrays. If you had a program, you were writing that in C, and you had a need for a variable length array or for a hash table, you probably wouldn't be motivated to write a hash table, implement a hash table that was as efficient as Python's hash table. So your program would probably run slower for the part that depends on that hash table. So in practice, Python is fast enough in real work. Lots of companies are very successful. I should mention that YouTube is implemented in Python. That's public knowledge, but few people actually realize that. There's an enormous amount of Python code involved in rendering every YouTube page. Now, obviously the video codecs and the streaming are not written in Python, but everything else, the whole user interface, all the logic, is all Python. And those guys know what they're doing, and sometimes they really have to use Python as sort of a glue language around custom C code, because they do sometimes write custom C code that does a particular thing faster. But nevertheless, all their logic is still Python, and they can focus on making only a few things fast. And of course, using lots of open source that also takes care of that. So a compiler certainly isn't the solution to making Python faster. Maybe a jet like PyPy is actually much more successful, because in many cases, even though it's hard from just looking at the source code of a module to really know what the types of the variables and parameters are, a JIT looks at runtime, and at runtime there are often very obvious patterns that emerge even when the code is written not according to some kind of sound type system or philosophy. So a JIT can often do amazing things just based on the evidence that a certain variable is always of a certain type, and can specialize that. So there are lots of ways to speed up Python. Compiler is not necessarily the right answer. So the global interpreter lock, the GIL, is also a great trolling subject. Especially people coming from the Java world are so used to the sort of the idea that starting a new process takes forever, because starting JVM just takes a long time. Starting a new thread is quick. Now in Python, starting a new thread is also quick, but starting a new process happens to be very quick as well. It turns out that Python internally supports threads as long as they're I/O bound. It does not support threads very well when they're CPU bound. So if you're solving fast Fourier transforms, say, and you want to do that on 16 CPUs in parallel, Python is not particularly good at that, because essentially the global interpreter lock does serialize your code so that only one thread has the CPU at any time. On the other hand, if you're implementing a web server, you can have lots of active threads, because probably most of your threads, most of the time, are waiting on I/O. Either they're waiting for a socket that gives them some more of the web input, or they're waiting on a database connection or some other scraping activity. So you can have lots of threads active. If at any point in time more threads are all doing something CPU intensive, they still have to compete with each other with the global interpreter lock. But for a web server, you probably want to be scalable beyond a single machine anyway. So what you want to do is you want to organize your web server so that you can have many processes all running essentially the same code in parallel. And then if you have 6 cores on your machine, you just create 6 processes. If you have 10 machines with each 6 cores, you just have 6 processes on each machine. If you're writing based on a shared memory model where you sort of believe that everybody needs to have access to all memory, you may be able to scale very easily up to the number of cores in one machine, but then scaling to the second machine is going to be much harder. So in effect, if you sort of write your Python program the right way, you actually benefit from sort of the GIL by it forcing you to sort of write your code in such a way that it doesn't depend on shared memory. Of course, you can still use shared memory with little care as a cache within one process, and you'll still have lots of threads probably, or you'll be using some other tool like Twisted or Tornado to handle to multiplex events. But sort of in practice, people who know what they're doing have absolutely no problem with the GIL. The reason that the GIL sort of got a bad name is that some people who didn't know Python very well sort of started out building something in a certain way that they didn't know that there was a GIL, and then they were surprised when their code didn't scale the way they had expected, and then they got very upset. Yeah, you can blame a lot of things on the programming language. You might blame it on your own paying attention as well. So actually, the third bullet is kind of silly. Why didn't you support real threads? Well, Python's threads are real threads. Python has operating system level threads, so they're completely integrated in all the scheduling that PyWest does. There's just a lock that actually the GIL makes things faster in a sense. We've had a number of people who experimentally try to replace the GIL with more fine-grained locks. So what currently happens is basically one thread has the GIL, and it can modify every object, like increment a reference count, insert an element in a dictionary or list. What they tried to do was instead give each object its own lock. And when you change an object, you have to acquire that object's lock then you can update the object and then you have to release it again. That's a lot of work, but you can do that. It's not too hard. I mean, the sort of the kind of discipline that you need for that is readily available. And hopefully, many objects aren't actually shared in practice, so you can have lots of threads that are manipulating lots of different objects in parallel, and they don't compete for those locks because they're actually manipulating different objects. It turned out that, unfortunately, single-threaded code runs twice as slow in that model, because instead of having one lock that you acquire, I don't know, every 10 milliseconds or so, and then you release it and then you acquire it again, every operation you do pretty much acquires a lock, and even if your locking operations are incredibly optimized, if the locks are small, nevertheless, a single thread just sort of manipulating objects runs much slower than in the case of the GIL. And so now you suddenly need 2 CPUs to make up for that. So it's not necessarily a great scaling tool either. I mean, it scales a little bit, but it's sort of disappointing. So I would say be happy, use multiprocessing, create multiple processes. Yes, question?
Is the GIL Python problem or C Python problem?
Very good question. It's a little bit of both. It is definitely a CPython problem. I believe that RPython and Jython, that's sort of the .NET and JVM implementation, do not have this problem because they use the sort of the native multi-threading capabilities of their platform. On the other hand, PyPy has its own GIL. Even though PyPy has a completely different runtime implementation and design and organization, it nevertheless ended up making the same choice as CPython. So anyway, my prediction is that at some point when we have hundreds of cores in a single computer, that shared memory is probably not going to work so well, and you'll have some kind of incredible cost for communicating to another CPU anyway, so message passing and multiple processes that are more or less independent might still look very good in that situation. Sorry, was there a question there?
Yes, there's another way to use multi-threaded Python effectively, that is with C extensions, because as far as I know, the GIL is released once the code drops into the C extension, and from the first example with the Fourier transform, I think if you're implementing the Fourier transform in Python, you're doing something wrong, especially if you want to run it fast. So I think in the cases where you actually write Python code to get a problem going fast, you're doing the main logic that's actually going to work in C, and then your problem vanishes.
That's a very good observation, and I agree that the FFT example was kind of silly. NumPy, for example, it's unfortunately it's not automatic. You can easily write stupid C code that doesn't release the GIL. And of course, C code that manipulates Python objects actually has to retain the GIL because it's not allowed to touch any Python objects. But for example, NumPy is a very good example. When you tell NumPy, oh, go sort of element-wise add these enormous arrays of numbers, those are no Python objects, there are no reference comments or any Python operation. So NumPy, indeed, whenever it does something like that, it releases the GIL. And so if your code is using NumPy and it's sort of CPU intense enough, and most of the CPU intense work is actually NumPy executing operations on large arrays of numbers, then you have no problem at all. That is a very good point. It's just that sort of when your program is not so nicely uniform, there's not like one big operation that is all implemented in C. It's more like a string lookup here and a dictionary there. It's not so easy to use that strategy. Okay, GIL. What else do we have? Asynchronous I/O, concurrency. That's sort of maybe a related topic. There are lots of interesting ways of handling concurrency that do not involve threads. For example, there's something called stackless Python. I heard at EuroPython actually that stackless Python is sort of alive and well. They're now at stackless 3.1, and it's now finally easy to install. It sort of moves to your CPython. But stackless Python sort of changes the rules of the game a little bit, and it really only works with CPython. It's essentially a variation of CPython that allows you to create, well, I forget what they call them, threadlets or tasklets. They're sort of lightweight threads that are only sort of explicitly switched. But because they don't use operating system threads, they can switch much quicker. There are other systems that do similar things, but all of them are tied to a particular implementation, usually CPython, but I think there's a Greenland's version for PyPy. Those things are very nice for certain types of applications. You do have to be aware that because they use microthreads, they're usually also not all that good at using multiple CPUs. So even though they let you very efficiently handle very large numbers of socket connections that only require a little bit of activity, they're still no good at multiplexing CPU-heavy operations on multiple cores. I think that asynchronous I/O and concurrency, sort of alternate models for concurrency that besides sort of traditional operating system level threads, or sort of the other extreme, which is just pure old-fashioned message passing or remote procedure calls. I think it's a very interesting topic. I don't know what the right paradigm is, and I don't think it would be a good idea to sort of prematurely commit to building one of those paradigms into the language. So I'm much happier with people experimenting with different ways of doing concurrency, and sort of all the way from pure callback-based programming like Twisted in Python, which you could compare to Node.js in the JavaScript world, to G-Event and Stackless, which are actually let you write much more synchronous looking code that sort of is concurrent under the hood, to a middle ground that I've been experimenting with myself based on coroutines that use the yield statement or expression as explicit switching points. I think it's an interesting topic. Maybe I should at some point explore it more and work it out into a whole presentation. I don't think that sort of any of the paradigms that have been proposed are ready for inclusion in Python. Of course, it's nice to see that other languages sort of pick something like Go has sort of integrated something called Go routines in the language, which are probably similar to stackless or G-Event microthreads. That's an interesting choice. We'll see how that works out. Oh yeah, this is another thing. Sometimes people get very worried because they foresee this future where lots of code runs in the browser, more and more complicated applications are written to run in browsers, and Python doesn't work there, and it probably never will, or at least not in the foreseeable short or medium future. It's a really tough problem. I wish I had been there when Netscape invented JavaScript. I actually knew someone at Netscape around that time, but they weren't exactly saying what they were doing. At this point, there is sort of a chicken and egg problem because Python isn't available in the browser. Even if tomorrow I added Python to one browser, I wouldn't get almost anybody to write their website to use that, because then they would sort of lock their users into that one browser. Getting all the major browser vendors to agree on adding a second language to their browser would be incredibly difficult, because they can't even agree on the dialect of JavaScript they support, or the exact version of HTML and then they really are. They are actually talking a lot about trying to sort of get agreement on that, because they all realize they want to move forward and not compete on who can emulate an Internet Explorer 6 best. But in the end, introducing a whole new language is not even on the agenda. And good luck if you want to do something about that. Maybe I should work for you if you have plans in that direction, or maybe I'll look at your plans and say it'll never work. In the meantime, there are various hacks that some people like. There used to be a bunch of people who thought that Java was the only correct language to use, and so they came up with a very interesting and complicated system for writing web applications in Java. There were actually several of those. First there was Java applets, which I think that once a year I encounter a website that still uses Java applets. Then there was Google Web Toolkit, which is also very interesting and definitely better than applets. It also seems sort of abuse of the Java language in many cases. And in the end, I don't think that a lot of people are going to sort of adopt the idea of writing web applications in Java, because it's not actually such a great language for that person, even with great tooling. But the Google Web Toolkit idea actually got some other people thinking, and they said, well, we don't like Java, but we do like the idea of translating our favorite language into JavaScript. So there is a project called, I think, Pajamas, Pyja, and it does exactly the same thing, and I think it even borrowed most of the ideas for its widget sets, from Google Web Toolkit. It's open source. I don't know actually what the current state of the project is, but they've been around for quite a while, and sort of they don't have the problem of not all web browsers support us, because they just translate to JavaScript. So if you want to write your in-browser web app in Python, try Pajamas. So another similar platform that also gives some people nightmares is mobile. Why doesn't Python already run on Android? Or other people sort of say, why doesn't Python already run on iOS, on iPhone? And well, part of this story is actually something that we should just discuss over good beer afterwards. But basically, it's really hard to get a second language introduced in an environment where there is essentially only one language, because sort of everything works in favor of one language. Once you're sort of in the situation, if you're in a situation where there are multiple languages happily working together, you can have a really nice ecosystem where multiple languages continue to thrive. And that's sort of what's happened on the server side, and PCs, and all sorts of places on the desktop. But on mobile, so far, it seems each vendor has one favorite language, and then there's JavaScript. So, sometimes it makes me depressed, and sometimes I think that it's hard to believe that most of the world's computing will actually eventually run in our pockets.
Symbian is a good example. Nokia tried to implement Python. It was a simple Symbian of
Yeah.
total failure.
Really? Yeah, I remember talking to that group, and they were sort of incredibly constrained by available memory, and they had really sort of really slow CPUs with really small amounts of memory, and that sort of worked against them. Then again, apparently they're not all that successful with other technology either at the moment. So functional programming, that's a particular corner of the my language is better than your language that often sort of gets brought. I still, every once in a while, a random stranger comes up to me and demands an explanation for why we removed the reduce from the language. And they've never used Python. They're more of a Haskell or Lisp fan. They like functional everything, but in their favorite online news source that has been always writing about Python and killing reduce. And the strangest was when for a while people started saying, "Yeah, but Google has map reduce. Isn't that the same as the reduce function?" Which seemed to sort of kind of miss the point, because the reduce function in Python has nothing to do with running large parallel batch jobs. I'm not even going to defend that decision. I still think it was absolutely the right decision. Oh, and by the way, you can just import reduce from standard library modules, so it didn't actually get removed, it just got sort of put in the corner. I like functional programming in those areas where it works. And there are lots of areas where functional programming is really cool. And if you don't know Haskell yet, I would recommend try to learn Haskell. At least sort of track down one of the many cool Haskell tutorials and sort of spend an hour or a day learning Haskell, and sort of stop where it comes to the monads, because you're not going to understand that. But you don't need that. You sort of getting a flavor of functional programming is very helpful to help you recognize when functional programming is useful and when sort of some of the paradigms of functional programming style, like don't modify objects in place but create sort of immutable objects, and just work on making operations more efficient that way. Recursive algorithms, sort of elegant transformations that can be combined in lots of clever ways. That's all wonderful stuff, and often sort of when you have a hairy piece of code, there's sort of a functional sub-problem that is a really good fit for a functional style. And then you have the other part, whether it's the I/O or interfacing to a legacy API or running some scripts that talk to the web, or any number of other things where if you were to do it in a functional language, you'd sort of be fighting against the functional nature of the language a lot, or you run into the monads. And it's possible, but it doesn't necessarily make it easier to write the code. And so in Python, I like that I can just sort of hack around all that and make a system that sort of works the way I need it to work at a certain point, and not be forced into one particular paradigm. And yeah, if that means there's something where I have a desperate urge to write it in C, I can do that too, and write the C extension. So we're actually doing pretty well for time. The standard library. This is hardly a troll, but it's an important topic to bring up. When Python was young, it had a standard library that was pretty cool and that was growing. And I personally put all kinds of nonsense in the standard library because it happened to be sort of something I was intensely interested in for 3 months. And with Python 3, a lot of those things finally got removed and thrown out, or in some cases reorganized and improved. But so when Python was young, everybody who wrote their own bit of Python code and came up with, oh my gosh, yeah, I haven't written an application, I've written a cool library, and I hope that other people will also use my cool library. And all those people sort of sent me the source code for their library, or at least the idea, and they said, oh, you should add this to the standard library. And sometimes I sort of did that. It was like a cool 35-line module. And I've learned over time that that's actually a fairly dangerous thing to do. So lately, say over the last 10 years or so, it's become much harder to get your code accepted into the standard library. Nowadays we have all kinds of things that we look at. It's got to be broad. You can't have sort of one particular type of application supported well by the standard library. If as soon as it smells of applications, we say, oh, just sort of make it open source as a separate package. Like a web framework, there will never be another web framework in the standard library. We have a GUI framework. That was probably a big mistake. We can't get rid of it, but we're certainly not adding any better ones. There's a fairly healthy ecosystem for third-party GUI libraries for Python, unfortunately. So people are rarely actually required to use the one that's in the standard library. But the one in the standard library is essentially stable in sort of the biological sense, which means dead. So nowadays, the last thing you actually want to happen to your code is for it to end up in the standard library. The standard library has a very strong backwards compatibility requirement. If you make a mistake in your API design, you're stuck with it probably for 3 Python releases anyway. And Python releases are 18 months to a year apart, so do the math. That's a long time to be maintaining a youthful mistake. If you want to add a new feature, if you're developing your library, you also have a problem because you can't sort of add a new feature and make a new Python release and say, hey, now standard library module foo also has a foobar method. No, you're going to have to wait until the next Python core release, which is probably going to be in 12 months or more. So for all those reasons, it's actually for almost all code, it's much healthier to be third party. We have a very nice packaging system. We have archived the PYPI. I refuse to call it PyPy because there's already something else called PyPy. It used to be called the cheese shop until someone pointed out that there wasn't actually any cheese in the shop. But anyway, PYPI is a really good place to publicize many versions of your package. Especially these days with virtualenv and vip, it's very easy for people to download and install your libraries. So I say, be happy to be open source and remain third party. And so there's still stuff that gets added to the standard library, but it's usually stuff that is essentially completely stabilized, like we're adding a library for manipulating IP addresses. Well, IP addresses aren't going to change very much in their syntax or semantics in the next 10 years. Well, that's a good thing to have in a standard library because many people in different fields have to do that. So don't ask for your library to be added to the standard library. Oh yeah, garbage collection is a typical trolling subject. People think that Python doesn't have garbage collection because it has reference counting, whereas reference counting is actually a completely respectable implementation of garbage collection. It's not too slow. Well, it all depends on how you implement it. You can make garbage collection as fast as or as slow as you want to. I once read a really nice paper where they argued that the best way of automatic memory management was actually a perfect hybrid solution that had many properties of sort of classic list style garbage collection, but also has many properties of reference counting. Basically, if you start with a pure reference counting system and you want to deal with all the different kinds of application behaviors, you have to add more of a classic garbage collector. But if you start with a nice classic garbage collector and you want to optimize it, you find that adding reference counts in certain situations is actually a great performance hack. So I think that Python already has the perfect garbage collector because you indeed use both reference counts. CPython, I should say, uses indeed both reference counting and the cyclic garbage collection. So no worries there. This is the last real slide. People always sort of complain that the languages are changing too fast, but they contribute themselves by pointing out all the missing features. That is a real problem. I think a local hero, Bertrand Meyer, proposed that for Eiffel, they should only add new features if they could first delete other features from the language. I've only heard this as an anecdote, but it strikes me as a reasonable point. Because in Python, often when people sort of write me, I get a lot of fan mail from people say, oh, Python saved my life. I'm so happy that now I'm using Python. And often it comes with some kind of commendation for how simple the language is. And clearly they haven't heard of meta classes yet, which is probably a good thing. But there really is a there's a lot of simplicity to the language, and it's nice and elegant. And as we add more features, the language might actually lose that simplicity and sort of lose its attraction. So by adding new functionality, even with the best of intentions to improve the language, you might actually make the language less useful because it becomes too hard to understand everything. So I say we're going to keep changing Python, but we're going to change it at a very slow rate. And we're going to change the standard library much more than we're going to change the language. Every once in a while we may repeat the idea of a language moratorium from Python. So long ago, I don't remember. I think it was between 3.1 and 3.2. We decided that for one whole release cycle we would not make any changes to the language proper. And we stuck to it. And it was actually pretty successful because it let us focus on library and distribution issues and so on. So languages sort of evolve at an ever slower pace. If you're designing a language, by all means, since you probably don't have many users yet, now's the time to change your language dramatically when you think you have a better idea, or when you try something out with 5 users and 3 of them think your particular idea sucks. Try something else. It's not too late. Once you have 1,000 users, it's going to be a little harder to change. But you should still change dramatically when you have only 1,000 users. So imagine when you have 1 million users, how hard it's going to be to make changes. By the time you have 1 million users, every change has to sort of be planned with a whole backwards compatibility plan and deprecation, and it all costs a lot more to make a change. In Amsterdam, they once renovated the central station completely inside and out. But all the time during construction, they also had trains and hundreds of thousands of commuters coming in, and that all sort of flowed. They did an enormous amount of work that was very costly. It would be much more efficient, in a sense, financially, to just tear the whole thing down and build a new station instead. But because they had to sort of deal with backwards compatibility, the station was already there and the commuters were coming and the trains had to go somewhere. It was much more expensive, so keep that in mind. It's much easier to do greenfield development, but after a certain time you can't afford it anymore. Okay, so that's time for questions. I believe we still have 20 minutes, is that right? Yeah. Okay.
Do you have resources or examples or tutorials how to design a language? because today everyone is running their own ESL. There is excellent tools, Xtext or Eclipse to write your own ESL, but I find we always have the same problems. For example, in Python I have the basic comma that I can use, which makes the code much more editable, because I can just delete the whole line and the syntax is clean. But things like that. Do you have anything?
That's a really nice idea. Every once in a while, someone writes me with sort of, do you have any advice for a budding language designer? But many of them don't actually have any idea what it even means to design a language. What they're really looking for is education on how to build a parser. And that's sort of, these days, that's the easy bit. So, yeah, how to actually design a good language? I don't think there's a very easy answer to that. You have to sort of combine sort of intuition with lots of experience. My own path to sort of designing a language definitely came from knowing a lot of different languages, and then working in a project where a team of 5 or 6 people was implementing a language that had been completely designed for us. So all we had to do was build an implementation. Through building the implementation, I learned a lot about language design, because often the implementation was not particularly easy, so we challenged the design. And the language designers who were still on hand, they were sort of managing the team, could always explain exactly why they designed the feature the way it was. And so that interaction with an experienced language designer, combined with sort of the hands-on experience of building the language implementation, we built everything from scratch. Tokenizer, parser, bytecode compiler, interpreter, objects. I think that sort of helped me understand what goes into language design and implementation. And sort of if you know nothing about implementing a language, but you're sort of an avid programming language user, you may not be able to design a language that is actually implementable. On the other hand, I've seen people who had sort of gotten a lot of fame for writing some incredibly cool compiler for a previously existing language, then try their hands at language design and not be particularly efficient. So yeah, it's not much of a guideline, but maybe I should think more about this. Thank you. All right.
If you could start from scratch today, is there something you would do different?
That's actually a great question, but I'm not going to answer it directly. Because I actually sort of developed a philosophy about this, which is that if I could start over from day, I probably wouldn't get anywhere. I was lucky to have started, well, it was more than 22 years ago. And I cut a lot of corners. There's a reason that sort of Python 2 had 2 types of classes. It had 2 types of integers. It had a bunch of limitations. There were like 2 different ways of doing exceptions. An exception could either be a string, literal, or a class. And you could say, well, if I'd known everything from the start, I would have implemented the right type of classes from the start, and I wouldn't have wasted my time with the sort of the pseudo classes we had before that. I would have implemented long integers only because the short integers were kind of a crutch. I would have done exceptions right, of course. Many other things, but in each of those cases, I actually save myself initial development time at the cost of a cleanup operation later. Now you can say, why not sort of not make any mess, do everything clean from the start. But it may take such a long time to do everything sort of the principled way that doing things in a sort of more ad hoc way, cutting corners intentionally, knowing that you're going to have to clean up, can be very effective. And so within 3 months, I had a sort of primitive version of Python, but very recognizable at Python. Most of the syntax was exactly the way it is today. Function definitions, all the different structure statements, assignment, everything worked, lists and dictionaries, and integers and floating point numbers. And because I had cut a bunch of corners, I had sort of a quick prototype that I could then develop. And had it been a bad idea, then the prototype only wasted 3 months of my time instead of the year it would have taken to implement the classes properly and the exceptions properly and the string data type properly and so on. So I think that often sort of not getting everything right the first time can be a blessing. And the other thing is that you don't always know which things are perfect and which things aren't. You may think that, oh, I'm doing these 4 things, and this one I'm probably going to have to redesign later on, and that one is perfect. Well, it might well actually end up to be the other way around. So you can't always know what your users ask you, and until they ask for it. And so this is another part of the sort of what makes a successful language designer, I think. Don't try too hard to be perfect the first time. Okay?
I was wondering what kind of role you had at Google as an illustrator.
Oh, that's very easy. I am an individual contributor on the App Engine project. Google App Engine is a sort of platform as a service in the cloud. Run your Python application on our servers, and we carry the pages so you don't have to. I've written many parts of the system. I didn't sort of come up with the idea. I joined the team when they had a completely working internal prototype that only supported Python, which I thought was pretty cool. Made me sort of want to join that team. Since then, I've written several client libraries, some completely from scratch. I've written a number of tools, some successful, some not so. Most of the stuff I've done is both implemented in Python and written for the benefit of the Python App Engine users. I feel that I'm part of the institutional memory of the team. Many of the original team members are no longer there. The team is growing at a dramatic rate at the moment. So I spend a lot of time mentoring new team members, telling them what sort of the philosophy of the system is. And then I get to spend my so-called Google 20% time on pretty much whatever I feel like in the Python community, like traveling the world to do Python evangelism, or writing a Python blog, or sort of bickering with the Python core developer community.
A question regarding online get etcher. Why is it catching the attribute error exception? It does it implicitly. So my question is really why isn't this done by get attribute?
I'm sorry, it sounds like a clear question. I'm not entirely clear on the feature that you're talking about here.
If get attribute raises an attribute except an attribute error,
Yeah.
it's catched by get attribute, not implicitly. So the language does it for you. So, but it may be really annoying because if I do some operations within a get attribute, it's
Yeah.
maybe cached.
I see your point. That is definitely a sort of a somewhat dirty corner of the language, I would admit, and we didn't clean that up enough for Python 3 maybe. I mean, one of the sort of unpleasant parts of it is that there's both get attr and get attribute, and there's not also del attr and del attribute, or set attr and set attribute. And so the full name get attribute was actually added later to be sort of the proper operation that sort of using proper subclassing and supercalls implements the basic get attribute operation. So get attribute is actually the sort of the closest relative of set attr and del attr. The original get attr was more a sort of a catch-all that you could implement to catch all, to only catch those attribute accesses that weren't implemented in another way. And sort of, it's unfortunate that get attribute, when it raises an exception, you can't tell whether it intended to raise that exception or whether it's a bug in the implementation of your get attribute that does that. And you would have to sort of, basically, you'd have to write your get attribute implementation very carefully to prevent that. My recommendation is actually to not implement get attr at all. I don't think I've written get attr book in a very long time. There's a certain style of delegation where get attr is a quick and dirty hack, and I don't particularly like quick and dirty hacks that much anymore. And it used to be the case that if you wanted sort of custom attributes that were dynamically calculated, that you had to use get attr, but we introduced a property decorator and property function in general for that purpose. So there are way fewer legitimate use cases for under get attr and under. But I agree, it's sort of a dark corner.
Is it going to be fixed in future versions?
Python 4. It's like, it's one of those things that's it's not bad enough that it's sort of, it's not so in front of you that everybody steps into it. So I don't see a great need to clean it up. Just sort of put some signs around it saying don't go here. Yeah, we have 5 more minutes or so, okay?
When you created Python, did you thought it would become this worldwide used language that can do from PDF manipulation to serving Google infrastructure, web servers, everything?
I had no idea. I was sort of, I've never sort of done much of the visionary look in the future, predict the future, or very high ambitious plans. We're going to organize all the world's information. That's never been me. It was more like, okay, I think I'm running out of time here. I have only 2 programming languages for my platform. One is C and one is Shell. And I have to write a whole bunch of applications. If I write all those applications in C, I can sort of predict from my past performance that I'll never finish. If I write them in Shell, I'll have crummy, but very crummy and sort of slow running applications. And so I need some language somewhere in the middle. I realized there was a spectrum of other possible languages in between. I could Well, I could have sort of decided to port Perl to that particular platform, and I don't know what the world would have looked like then. But I decided to somehow have fun and implement my own language because my manager was gone for a half a year.